Alright guys, I'm going to try to show you how to find max and min values. My last video was 16 minutes, so a little bit too long to upload to YouTube, so I want to see if I can make it a little bit shorter. Alright, so max and min values. I want to come back to that graph. I want to actually define a couple things. So first of all, the function f has an absolute maximum or global maximum at c if f of c is greater than or equal to f of x for all x and d. F of c is the maximum value. So what we're saying is that this is definitely going to be bigger than all of the other y coordinates. So we would call it it's called a global maximum, or we just a lot of times we say an absolute maximum. If a function has an absolute minimum at a particular x value c, that means that that particular y coordinate is definitely the smallest. It's the lowest value out of all of them in the entire domain, and that's what the capital B is. And we say that the y value, which is going to be the f of c, is the minimum value. So it's absolutely the lowest. So I'm going to just go quickly, and then you can always rewind, pause, etc. if I actually get this on YouTube. Both of those, the absolute max and the absolute min, we call extreme values. It makes sense because they're extremely high or extremely low. Alright, now what's the difference between an absolute max or min and a relative or local max and min? Well, a local max and min is just the biggest or the smallest in a particular little area. It's in a little open interval containing c, and it's not necessarily the biggest or smallest, it's just the biggest or smallest in that general area. So it's a little bit of a high or a low point for a particular interval. So we'll see an example, but these are the definitions for relative max or local max. I'll kind of use those terms interchangeably. If it's relatively the biggest, because it's in a certain area, relatively the biggest, or locally, at least in that little local area, it's big or small. Okay. All right. Let's actually go back to the graph and let's see how those terms apply. All right. So if you look at this picture, we've got out of this graph from A to F, it looks like we definitely have a lowest point. And so we would say that that E right there is the absolute lowest value, so it's the absolute min. It actually also is a local min. And then this one up here, the D, is absolutely the highest, so we call it the absolute max, and then it's also called the local max. And then at C, we have a local min. You can see that it's the lowest value, at least in this general area, little neighborhood here. Some books call it a neighborhood. And then this B is a local max because at least it's pretty high compared to the y values around it. And then that's pretty much it. Relative max and local maxes cannot be on the endpoints. So you can have an absolute max and min at the endpoints, but the relative max and mins are not going to be at the endpoints. They're going to be at open intervals. Okay. So, next thing we talk about is the extreme value theorem. Now, the extreme value theorem, it says this: if f is continuous on a closed interval a to b, then f attains an absolute max value and an absolute min value at some numbers c and d. So basically, it doesn't really say a whole lot. What it basically says is you definitely have a high point and you definitely have a low point on every single interval. As long as it's closed, on both sides, then you're definitely going to have a high or low point. So I drew a couple of really, rough sketches of a curve here, and we could draw a whole bunch of curves, and they would all have a high and a low point. The absolute highest, so this would be the absolute highest for this curve, and this would be, maybe the lowest value for this particular curve, and this is the highest value for this little curve. So every little drawing that we do, we're definitely going to agree that we're going to have a highest and a lowest point. it doesn't help us. This theorem doesn't help us find anything. It just tells us that it exists. All right. Now we start getting into things that help us find the max and mins. The first thing is the critical number. This is an important concept. So the critical number is a number C in the domain, so it does have to be in the domain, such that either f prime of C equals 0 or f prime of C does not exist. So either the first derivative equals 0 at that spot, at that particular x value, or at that particular x value, you don't have a first derivative. So there are spots where the first derivative has issues, like maybe you're dividing by 0, so you don't have a first derivative at that spot. Those are going to be critical numbers. Okay? Alright, let's do a problem. I have this worked out because I obviously already worked it out and recorded it, but I'm just trying to make it less than 15 minutes this time. Alright, so find the critical numbers. So we start off with f of x equals 4x cubed, you know that function there. And we just have to take the derivative. So I found the derivative using the power rule. And then I set it equal to 0. We're trying to figure out where the first derivative equals 0. And then I factored out a 6. So that's always a nice idea. Factor out a number if you can. Make the number smaller. And then now you can factor it really nicely. Set your factors equal to 0. And those are your critical numbers. -1/2 and x equals 2. And those become kind of important numbers because this is a rough sketch, this blue sketch. And you can tell that I plugged in -1/2 into the original function and I got 6.25. And I plugged in 2 into the original function and I got -25, I believe. And those actually are relatively high and low points. So this at -1/2 turns out it's relative max. And then at 2, -25, that's a relative min. But I was just focusing on finding the critical numbers. Alright. Next thing, this is really the most useful out of all the methods. This is called the closed interval method. And it says, if you want to find it's good for finding the extreme values, it's got the high and the low values, which have tons of applications. So, the way you do it, it's really simple. You just find the critical numbers, you take those critical numbers and you plug them into the function, and you see, what the y values are. So those are the numbers that you track. That's step 1. Step 2, you have to check the endpoints. So whatever your interval is, if your interval is a to b, then you've got to check a and b and plug those into the original function and see what the y value is. See if it's really high or really low. That'll be, a possibility as to whether it's the highest or lowest. And then third step, gotta move this one in here. The third step is that you just look at those numbers and then just pick the highest one out of all those, and that's your absolute max. And then whatever is the smallest one, that's your absolute min. So it's really simple. Find critical numbers. So you find the critical numbers, you try those. And then second, you try your endpoints, and then whichever one's the highest is the max, whatever's lowest is the min. Alright, so let's see here. Let's do an example, and we should begin. Alright, example, find the absolute max and min. So we start off with this function, f of x, which equals 3x squared minus 12x plus 5. And we're talking about the interval 0 to 3. And first thing we do is we find the derivative. So that's what I did. Found the derivative equals 6x minus 12. And then we set that equal to 0. And we find out that x equals 2. So then we try to plug the 2 into the function. So plug it in right here into the function. And we find out that f of 2 equals -7. So we just kind of keep that in mind. Then we try our endpoints. So that's step number 2. We try the endpoints. So I plugged in f of 0, and I got 5. And we can tell that pretty easily. And then I plugged in 3, and I got -4. And then what you want to do is you want to make a little table. I noticed that your p-test on the third response, they have this little table. So you just plug in whatever your critical numbers are, and then also your endpoints. So you'll notice I have everything here, little x and little f of x, and then I just look and I see, oh look, the 5 is the biggest, so that's the absolute max at x equals 0, and the actual max value is 5, and then the absolute minimum value is this one here at negative, an absolute min value of negative 7 at x equals 2. Okay? So that should be good. Let's try it out.